So let's see the part 2 of electrostatics. Electrostatics. So 14 question number, 2 point charge A and B having charge plus Q and minus Q. So A and B are 2 points. It is having plus Q and minus Q. 2 point charges are there. They are placed at a certain distance apart and force between them is F. So there is force acting between them, that is F. 25% of A is transferred to B. So right, 25% of this charge is transferred to this B. Right, then the force between charge will become. So as we know from Coulomb's law. So F is given by, it is K Q square upon R square. 25% of this is transferred. So it will become Q upon 4, right? 25%. 25 upon 100 is nothing but it is 1 upon 4 now. So I have divided by 4 here directly. So new charge is will become of A is Q minus Q by 4. Why I have subtracted this much is transferred, right? So now take the LCM. So it will be QA equal to LCM is 4. So it is 4 Q minus Q. So it is 3Q upon 4 is equal to QA, right? So charge of B is given by next B. So B having carrying charge minus Q. So how much charge is added? Q by 4. So this charge is increased in that. So take the LCM. It is 4. So it will be minus 4 of Q plus Q. So it will become minus of 3Q upon 4. Right. So this is the condition 1. This is condition 2. Now we will apply the formula if. So it is given by F equal to K Q1A, Q of charge A, Q of charge B divided upon R square, right? So now put the value. So F1 is equal to, it is K, this is your QB, right? And this is your QA. So put here value. So it will be K 3Q upon 4 whole square because numerical value is same, right? So it will be squared. So F1 will become now how much it is? So it is K 9Q square upon 16R square, right? So it is 9 upon 16. So, and 9 upon 16 into F. So this will be the F1 equal to, right? And right here the F is nothing but it is KQ up KQ square upon R square. KQ square upon R square. So this is the F formula which is valid when charge and distance is there. So this is the relation between F1 and F. So please write it down fast. Now look at the question number 15. Two parallel infinite line with linear charge density is given. Lambda. Lambda is nothing but linear charge density. Linear charge density. Right. So lambda formula is unit is coulomb per meter. It is nothing but charge upon distance. So charge unit is coulomb and distance unit is meter. This is called linear charge density. Understood? So 2 point charges are given which are parallel to each other. So this is lambda, this is minus lambda with negative charge density at a distance of 2r. So distance between them is 2r. Right? What is the electric field midway between the two lines? So you have to find the midway line. So the formula when it is linear charge density, so formula is for electric field is E1 is given by lambda upon 2 pi epsilon naught r. I Newton per coulomb. Right? I is nothing but it is your current or Note current here, it is unit direction. Unit direction. So what is unit direction? You can see here. So this is your x-axis, this is y-axis, this is your z-axis. So it is given by unit direction I, J, and K, right? So this is your lambda 1. Similarly, for the lambda 2, electric field is given by lambda upon 2 pi epsilon naught r. Direction is I Newton per Coulomb unit. So net electric field will be the addition of E1 plus E2. It will give the net electric field. So it is E1 plus E2. Now put the value. So it will be lambda upon 2 pi epsilon naught r I plus lambda I upon 2 pi epsilon naught r. So it will be 2 lambda I upon 2 pi epsilon naught r. So it will be coming out to be lambda upon pi epsilon naught ri. So this is the answer. Please write it down fast. Now look at the question number 16. In the circuit shown below, the reading of the voltmeter and ammeter will be. Right. So it is asking about the reading. So first make the diagram. This is your 10 ohm resistor that is given by R and current is passing through it. So there is potential difference applied through it. And this is your ammeter to measure the current. So ammeter measure the current. V is your potential. So they are connected with the potential difference that is 10 volt plus minus. So see for the first one, since galvanometer resistance for the ideal emitter is 0, while the ideal voltmeter is infinite. So write the statement here, galvanometer resistance for an ideal emitter is 0, 0, right? Now for the ideal voltmeter is infinite. What is infinite? Resistance. Right. So V1 we will calculate as V1 equal to V equal to IR. So it is I1 into 10. So current is nothing but it is given by 10 upon 10. Right. As we know V equal to IR. So I is nothing but it is V by R. Right. So V is also 10 here and R is also 10. So 10 by 10 is 1 and it is already 10. So it is cancelled. So V value is 10. So this potential is applied here and this is in the series connection. So voltage will be these 2 points. So this voltage is coming to be directly V1. Now for the second case diagram is like this. This is 10 ohm again. Here 10 ohm resistor is connected through it having voltage V2. Right. It is connected to it and ammeter is also connected to measure the current. So it is also 10 volt. Current passing through is I2. So calculate V2 equal to I2 into 10. So how will you calculate I2? It is also 10 by 10. The equivalent of these two is also 10. So it is 10 by 10 into 10. So it is coming out to be 10 volts. So V1 is equal to V2. Right. And I1 is also equal to I2. It is 1 ampere only. So write it down. It is also asked in NEET 2019. Now look at the question number 17. So suppose the charge of proton and electron differs slightly. One of them is minus E and other is plus E plus E. Right. So one is minus E and another is E plus E. Right. If the net F, electrostatic force and gravitational force between two hydrogen atoms at a distance d. Right, hydrogen atoms are there carrying the F force between them at a distance of d. Atoms are placed. So delta E change in charge, you have to tell it. Asked in 2017. So see the explanation. F. So Fg is equal to F of E. So F of E is electrostatics force. Electrostatics force is this. And this is your gravitational force. Gravitational force. Gravitational force. So it is given by G m square upon d square. Gravitational force is equal to K delta E square upon d square. Distance is so it will be cancelled. So delta E square will become G m square upon K. Now put the value. G is gravitational constant, that is 6.627 10 raised to of minus 11 into, that is 1.67 10 raised to of minus 27 square divided by. So K is nothing but it is 9.8 into 10 raised to of minus 9. Right. So delta E square will be coming out to be 2.1 into 10 raised to of minus 74 coulomb square. So delta E will be equal to 10 raised to of minus 37 coulomb. So this is the answer. Please write it down. So next numerical will be based on electrostatic potential and capacitance. So first question, it is asked in 2021. 27 drops of same size are charged at 200 volt each. So there is drop whose voltage is 200 volt, which are charged. They combine to form a bigger drops. So number of drops is 20. So it will form the bigger droplet. Right. Calculate the potential of the bigger one. So see the explanation. Right. So total drop number of drops is given. 27 are given, not 20. It is 27. So total number is given 27. Right. So total volume will become how many? So it will be volume is equal to 27 into a sphere volume is 4 by 3 pi r cube. Right. And as we know, r will become 3r. So for a smaller, this is V means volume, and capital V means potential. So it will be KQ upon R. This is your potential value. Right. So potential given, that is 200 K. So it will be KQ upon R. So this is the equation 1. This is your 2. Now see the next point. So next one is V1 equal to KQ upon capital R. Right. After the forming the for the larger drop. So for the larger drop potential. This is for smaller drop potential. Right. So this Q is nothing but it is 27 of small q. Right, the small q then. So this V1 is equal to 27 upon 3, 1 upon 4 pi epsilon naught q upon r. So this V1 is equal to, this will become 9 into, and this value we know from the second equation, that is 200. So into 200. So it will be 1800 voltage. Will become the new voltage. Understood? Now look at the second sum. Electrostatic force between metal plate on isolated parallel capacitor having a charge Q and area. Capacitor is C and A is your area. Right. So how they are related? See, F equal to QE. and Q. E value we know sigma upon 2 epsilon naught. So it is become Q square upon 2A epsilon naught. So it is which is independent of the distance between the plates, right? So sigma is nothing but it is given by charge upon area. Charge upon area. So here instead of sigma, we have taken this Q and A. So this is the A formula. So F is nothing but force and E is your electric potential. It is given by sigma upon 2 epsilon naught. So please remember these three formula 1, 2, and this is your third. Right. So independent. We are not getting distance formula here. So it is asked in 2018 in AIPM. Write it down fast. So let's see the third sum. A capacitor is charged by battery. C is charged by voltage. Battery is removed and another identical uncharged capacitor is connected. So battery after some time removed and it is connected with the new charge potential, that is C1. So as we know, energy is given by Q square upon 2C, right? So now Q dash is Q. So C dash will become 2C. So E dash will become, right, 2C. Capacitor is 2 times. So what will be the new E dash? It is nothing but it is E by 2 will become half of that. When charge capacitor double, electric potential or voltage will become half. So remember this relation, they are inversely proportional. So total electrostatic energy of resulting decreases by the factor 2. Now see the question number 4. Fourth is a parallel plate capacitor of area A separated D. Capacitance C is filled with 4 dielectric material having dielectric constant K1, K2, K3 and K4. Right, as shown in the figure. So there is diagram given to it. So distance between these two plates is D. So there is different type of dielectric constant. This is like this. This is parallel. This is like this. So area is A1 by 3, A1 by 3, A1 by 3. This is K1, this is K2, this is K3. And total will be K4. Right. And this distance is D by 2. So look at the fourth one. So it is given by C1 equal to 2 epsilon naught K1 into A divided by 3D. Similarly, C2 is equal to 2 K2 epsilon naught A upon 3D. Similarly, for C3, it is 2 epsilon naught K3A upon 3D. Now for C4, it will be 2 epsilon naught K4A upon D. Right, whole D will be taken. So they are in parallel, right? 1, 2, and 3. And resultant of these three is in series with this. So it will be 1 upon CAB. Capacitance is inversely added. So it is 1 upon C1 plus C2 plus C3 is 1 upon C4. Right. So it will be 1 upon K epsilon naught A upon D is equal to 1 upon 2 epsilon naught A upon 3D. And this will become the K1, K2 and K3 plus 1 upon 2 epsilon naught A upon 3D into K4, right? So we have put the value of C1, C2, C3 from this formula 1, 2, 3 and 4, right? In fifth one. So this is your fifth formula. Put all this value here.
नहीं
right?
ચાલશે ઠંડી લાગે છે.
Right. So cancel all the common terms. So these are the common term coming out here. So it will be equal to 1 upon K is equal to 3 upon 2 K1 plus K2 plus K3, right? Plus 1 upon 2 K4, right? So it will become then 2 upon K is equal to 3 upon K1 plus K2 plus K3 plus 1 upon K4. So this is the formula we are getting as a resultant.